So what we're going to move on to now is an idea called perpendicular gradients, okay? So let's have a look at perpendicular, well, we'll look at perpendicular lines first. So, in fact, I want you to divide the board up. So we'll do perpendicular lines on this side, and we'll do parallel lines on this side. Now, we're actually going to start with parallel lines. Can you tell me what does parallel mean?
It's line like this.
So they're both facing in the same direction?
Yeah.
Good, fantastic. So parallel literally means they face in the same direction. Okay. So what I want to look at is the features of parallel lines. So if I have two lines that are parallel, so let me draw in a set of axes again. Let's suppose I have a line like this, which I'm going to say is L1. And let's suppose I have a line like this, which is completely parallel, which is going to be L2. So you're happy those are parallel lines, they face in the same direction. Okay. Now, are you happy these two lines can have different y-intercepts? Okay, because look, that y-intercept is all the way up here. So the y-intercept for line 1 is up here. The y-intercept for line 2 is all the way down here. So they can have different y-intercepts. In other words, they have different heights. Okay. But what has got to be the same if these two lines are parallel?
They have the same things.
Same what?
Like the M.
Good, fantastic. It's the gradient, yeah? So they have to have the same gradient, okay? Because if you remember, the two things that define a line rather, is y-intercept and the gradient. Those are the two things that we looked at right at the very start about an hour ago. Okay? So the two ways of defining a straight line is the y-intercept, that's defining the height, and the gradient, that's defining the direction. That's how you define a straight line. So we've just said that with parallel lines, clearly they can have different heights. Okay, they can have different heights. But they have to face in the same direction. Well, the thing which tells us the direction of a line is the gradient. Okay? So for parallel lines, they have to have the same gradient, okay? And that's it, okay? So for parallel lines, if this gradient is m1 and this gradient is m2, it just simply means that m1 has got to be equal to m2. That's it, okay? And that's all I really want to say about parallel lines, okay? So if two lines are parallel, it just means they have to have the same gradient. But the y-intercepts can be different, that's fine. So that's parallel lines. What about what's perpendicular? What does perpendicular mean?
Are they crossing each other?
They could be crossing each other. They will cross eventually. Yeah, absolutely. But I mean, with these two lines, for example, so if this is say like L1 and this is L2, they cross each other, but would they be perpendicular?
No.
Why not? Okay, so perpendicular. The word perpendicular means at 90 degrees to. Okay, so they have to be at 90 degrees to each other. In other words, have to be at right angles to each other. So these two lines would be perpendicular, okay, because the angle between them is 90 degrees. Okay, so it has to be 90 degrees. Okay, so in fact all of these are 90 degrees. That makes sense. The feature of perpendicular literally means it has to be at 90 degrees to each other. Right? So let's see, we just said that the parallel lines, the gradients are the same, okay? Let's see what the feature is of the gradients of perpendicular lines. So here's what I'm going to do. I've drawn myself out a set of coordinate axes, and I'm just going to do it generally, and let's see what we notice, okay? So let me draw out, first of all, a line. So let me draw a line like that, okay? Now this line is going to pass through 0, 0, and it's going to pass through some general point up here. So I'm going to call this point P and Q, all right? So I'm just saying it's just going to be some general line segment In reality, this line will carry on forever and ever and ever in each direction, but I'm just going to draw the line segment between 0, 0 and PQ. Okay? Now, are you happy that I could form a right angle triangle from this? So think about what we're doing with gradient, midpoint and distances. I can form a right angle triangle from this really easily by dropping a perpendicular down here to the x-axis and dropping a line across here. Okay? So that line there would be a right angle. Okay? Now, what would the distance of this line be? So from here to here. So from here to here. What would the distance of that be?
Is it 8?
Where do you get 8 from?
Few-
So this is just some general point. P and Q. They're just letters.
I see them 8.
So from here to here, would you be happy it would just be P?
Yeah.
Yeah, because that just literally says how many you move across from where? From the origin. So in other words, that distance from there to there must be equal to P. So the distance from there to there must be equal to P. What's the distance from here to here?
Q.
Fantastic. Yeah, it's Q. So that distance from there to there is just equal to Q. So I've got myself a right angle triangle then. I'm not actually going to work out the distance of that line. I just really wanted to label on the x direction and the y direction. Now, because I'm going to be looking at perpendicular lines, what I'm literally going to do is take this line and rotate it through 90 degrees. So I'm going to give it a name. This line I'm going to call L1. So the one in blue I'm going to call L1. Okay? Could you tell me what would the gradient of L1 be?
We have to like 2 points.
So the other point would be 0, 0, wouldn't it?
Yeah.
Yeah? So it's going to be Q minus
0.
good. Divided by
P minus 6.
good. And what would that be?
P over Q.
Just Q over P, wouldn't it?
Yeah.
Yeah, that way around. Good, well done. So in other words, the gradient of line 1, the one in blue, is just going to be Q over P. Now, because I'm looking for perpendicular lines, I'm looking for a relationship of the gradients of perpendicular lines, what I'm going to do is I'm going to take this triangle, this right angle triangle, and rotate it through 90 degrees. Okay? So would you be happy if I rotate it through 90 degrees, this side will just rotate up to on the y-axis instead of the x-axis? Okay? And then this side will kind of be horizontal, and this side will kind of be facing out here somehow, like that. Okay? So therefore, this side here will still be Q, and this side here will effectively be just P. Okay? And that'll still be a right angle. So basically, if I rotate this solid blue line through 90 degrees, in this case anti-clockwise, I'd end up at this red line here. Okay? So this I'm going to call line 2. So are you happy that line 1 and line 2 are perpendicular to each other? Okay. What would this point here be? Yeah, just in terms of letters. So how many have you moved back by? What's the x coordinate?
1.
Isn't it Q?
Yeah.
Because literally this distance here is just Q, and it's telling you the distance from here to here, moving across the x direction, is just Q. But because you're moving backwards, would you be happy it is?
Negative.
Good. Negative Q. That's the x coordinate. What's the y coordinate going to be?
Negative P.
Well, have a look. You're moving from here. You're moving P, but is it positive or negative?
Positive.
Because you're going upwards. Fantastic. So there's this point here will be negative QP. Now, what this means then, if I just get rid of all of the dotted lines that I filled in, so get rid of all of that, what I'm basically saying here is that this is line 2 in red, and this point here is now negative QP, and this is line 1 in blue, and this point here is P and Q. Okay? And that's just, the way we should work that out is just simply what happens if we rotate that right angle triangle by 90 degrees to make it perpendicular. So therefore, the angle between these two lines is 90 degrees. What's the gradient of this line here? What's the gradient? Bearing in mind it also passes through the origin, 0, 0.
P minus 0.
Good.
Over negative Q minus 0.
Well done. Which are you happy would simplify to negative P over Q? Happy with that? Okay. So I'm doing it generally then, so it looks a bit weird because I'm using P's and Q's rather than numbers, okay? But this is what I want you to notice. L1 and L2 are perpendicular to each other. Are you happy with that statement? Okay. This is the gradient of the first line, and this is the gradient of the second line. So let's see if we notice some pattern between them. So let me write it out underneath. Let's get rid of all of this actually. So let's just write it like this. So the gradient of L1 is Q over P. And the gradient of line 2 is just negative P over Q. So what do you notice the difference? Okay, so this is the gradient of our first line, our blue line, and this is the gradient of a line which is perpendicular to it. What do you notice about the gradients? Is there any relationship between them?
Negative and minus.
Sorry?
Negative and minus.
Good, so you've got a negative. So one is positive, one is negative. Yeah?
Positive, and it's opposite.
What do you mean by opposite?
Like Q over B and B over Q.
Fantastic. So do you know what that relationship is? You see Q over P, you flip it and it becomes P over Q. Do you know what that relationship is when we flip a fraction upside down?
Yeah, it will be negative.
We give it a special name. If we flip a fraction upside down, it begins with an R. I don't know whether you're familiar with it. So you notice that perpendicular lines have, well, you have a negative, so let's write negative like that. If we flip a fraction upside down, we call it the reciprocal. Okay, so negative reciprocal gradients. Okay, so the negative just means one's positive, one's negative, and reciprocal just means when you flip a fraction upside down. Okay, so as an example then, let's see if we can create some space. If I tell you here what the gradient of two lines are, so let's say the gradient of line 1 I'm going to put in the first column, gradient of line 2 I'm going to put in the second column, so let's create a little table here. If I tell you that the gradient of a first line was equal to 2, what would the gradient of the line perpendicular to it be?
Negative half.
Good, negative 1 over 2. And you see that because of course 2 is really 2 over 1, isn't it? Good, well done. Okay, what about this one? If I give you that line 1 has the gradient of 3/5, what's the gradient of the line perpendicular to it? It's 3/5.
5 over 3.
Just 5 over 3? Negative, good. Negative 5 over 3. If I tell you the gradient of a line is negative 10, what's the gradient of the line perpendicular to it?
1 over 10.
Perfect, well done. So did you get the idea?
Yeah.
The relationship between perpendicular lines, you just make it negative reciprocal. Okay? You also notice that if I was going to multiply these two things together, the Q and the Q would cancel, the P and the P would cancel, and I'd just be left with negative 1. So another way that I could write this is that if I multiply these two lines together, the gradients of the two lines together, I should just end up with negative 1.